So we are going to start a new topic, uh, hybridization of organic molecule. So hybridization actually we have studied in chemical bonding. If you haven't studied the hybridization, then refer to hybridization from chemical bonding. That is the portion of inorganic chemistry. So here we are gonna go through a little bit introduction of hybridization over the only organic molecules. So what actually hybridization means that we're gonna see in inorganic. Now here we're gonna see every molecule attains that geometrical shape in which its energy is minimum and stability is maximum. So every hybrid orbital try to arrange in space such that it has the least repulsion and maximum stability. So basically hybridization is not the factor which is responsible for the shape of molecule. Not responsible would be incorrect. Which is responsible for the shape of molecule, because when they try to rearrange in spaces like that repulsion is minimum, then obviously that will be only the factor which represents its orientation in space, then which decides its shape of the molecule. Remember, hybridization is not term for molecule. It is not for molecule. Hybridization is the term we use for atom. So we do not use the term hybridization for the molecule. The hybridization only we can define for an atom, or it is only for the atom. So after the hybridization, what is the shape of the molecule? Like CH4, it is a tetrahedron. And H, ammonia, it is pyramidal. HOH, it is bent or V shape. So actually all of these three belongs to sp3 hybridization. If you refer to the inorganic chemistry, then valence shell electron pair repulsion theory explains the bond angle and everything about these compounds. So we will not go that much deep in organic for that. Okay. So if we count the number of sigma bond plus number of pi bond, number of sigma bond plus number of pi bond is 4, and if it is 3 and if it is 2, then what will be the hybridization? Actually number of sigma bond and number of pi bond, it is called the steric number, and if the steric number is for hybridization is sp3, steric number is 3 hybridization is sp2, steric number is 2 hybridization is sp. we do not go beyond 4 in organic, because in organic generally most of the case we will be finding the hybridization of carbon, and it do not have any empty d orbital, so it cannot expand it valency greater than 4. Now what is the percentage s character? What will be the percentage s character? It will be having 25 s percent, 33.33 s percent, and it will be having 50 s percent. Now if we talk about the increasing percentage of s character, if we go top to the down, electronegativity increases. You can say more the percentage of s character, more will be the electronegativity, because s orbital is more closer to the nucleus as compared to other subshell like p subshell or d subshell. Then more the percentage of f, more will be its electronegativity. Now if we say if we talk about C negative atom, if it is C negative atom, then negative charge, lone pair considered in hybridization, because if we have CH4 bond, now we can see, we will be saying that it has sp3 hybridization, because there are 4 sigma bond. When hydrogen goes, it goes like H plus, and it gives the negative charge to carbon, so it comes a lone pair, so still its hybridization is sp3. But remember, if it is like C double bond C, C negative, then this negative charge will not participate in hybridization. Because why it will not participate in hybridization? Because it can delocalize. It can be delocalized. It will be delocalized. This negative charge will go here and will go here. We will be studying detailed in resonance that it is taking participant in resonance, and it's that empty p orbital is in parallel empty p orbital with these pi bond. Again I'll refer that topics are belong to majorly to chemical bonding, but for a while you can stay, and we will be looking more detailed that in the resonance. So the negative charge will be in conjugation with the double bond, so that because it is in conjugation, then pf orbital has to be parallel with the pi orbitals of that double bond, so it is not in a hybrid orbital. So like if we have CH3, CH2 and CH2 minus, here the hybridization of carbon will be sp3, and if we have CH3, CH2, CH2 and if we have CH2, CH and CH negative, then it will be sp2 hybridized carbon. Now finally we will be doing some problems related to hybridization, so I'll refer you to pause the video after I write the question, then answer by your own, then look at the solution. Like if there is a question, mention the hybridization of each carbon. We have to mention the hybridization of each carbon. Here it is, here it is, here it is, here it is. So again pause the video and answer by one, and here okay, let's see. This corner is sp3 hybridized, this corner is sp3, this carbon is sp3, this is sp3, this is sp2, this is sp2, this is sp2, 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 sp3, sp, sp and sp3. How I am doing? The number of sigma bond plus pi bond, I am calculating the steric number, and I have explained that I have steric number 4, the hybridization will be sp3. Steric number 2, the hybridization will be sp, and steric number 3, and the hybridization will be sp3. 4 means sp4, sp3, 3 means sp2, 2 means sp. So that's how we're gonna solve the question related to hybridization. Now we're gonna draw a number of sigma bond, pi bond. We're gonna count the number of sigma bond and number of pi bond in the given structure. This benzene and this. Calculate the number of sigma bond and pi bond. So here the number of sigma bond are 5 and pi bond are 1. Why 5? Because we haven't shown the hydrogen. 1, 2, 3, 4 and 5. Now here the number of sigma bond are 14 and the number of pi bond are 2. How 14? 1, 2, 3, 4, 5, 6, 7 hydrogen, 8, 9, 10, 11, 12, 13, 14. So that we do not mention the one hydrogen. And here benzene has, actually very important, 12 sigma bond and 3 pi bond. How 12 sigma bond? Most of you will be assuming that it has 6 sigma bond, but the hydrogen we haven't mentioned over here also a sigma bond. Like here also, how many sigma bond? Here will be having 30 sigma bonds, because like 12 of hydrogen, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and no, sorry, not 30, 9. Okay, let's just erase this thing. Yes. 1, 2, 3, 4, 5, 6, 6, 6, 6 and 6, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21. It has 21 sigma bond and 1, 2, 3, 4, 5, 6. 6 plus 12. 6, 7, 12. 6 plus 12 is 18. 19, 20, 21. And number of pi bond are 3. So that's how that was all about we can say about the number of sigma bond and number of pi bond. The hybridization, again I am telling that it is the topic of inorganic, and we will be dealing the resonance and all the stuffs mainly in organic portion. Okay.